Alrighty, guys. Thank you for being on time. We're going to go ahead and get started. This is the, I wouldn't call it introduction to zoning, but it is the zoning class that I teach. It does assume that you have a good foundation in airflow theory and various things like that. So we're not going to dwell too much on that, but we will touch on it a little bit. But my name's Ethan Smith. I work for GA Larson. I'm based out of Salt Lake City, Utah. Also on the call, we have Keith, who's out of Denver, and Larry, who's out of Green Bay, that also work for GA Larson and do what I do. They'll be helping out tonight as needed. Guys, feel free to jump in, ask questions. I want to make this as an open forum as possible. I've taught this class probably a dozen times in the last 2 years. So I'm definitely not doing it for my benefit. So this class is for you guys. So if you have questions or concerns, please get them taken care of. You can either do that through the chat or you can unmute your microphone and feel free to speak up at any time. Couple of the things that are available out of this class, if you guys would like the manual that I referenced, which is the zoning applications manual that I'll show you in a little bit. I'm happy to send copies of that out. I just need you to email me. My email address is ethan.smith@GA-Larson. I'm going to put that in the chat along with my cell phone number. And you guys can reach me at any time, but if you'd like a copy of that manual, go ahead and shoot me an email after class and I'll be happy to send you a copy of that manual. So there's that email address and my phone number in the chat. So if you don't have that, go ahead and copy that down. So anyway, we'll go ahead and dive in here, guys. I will at various periods through the class ask for class participation. The class is a lot more fun if you guys do speak up and speak your mind, and there's no shame for incorrect or partially incorrect or flat out wrong answers. We all learn from anything that's said. But I've got a little bit of a PowerPoint, and then I've got some practical exercises that we'll do on my end that you guys will be involved in. So please pay attention and feel free to participate to get the most out of the class. We'll get out of my presentation of shame. And so this is the zoning application class. I know we've probably got some guys from Idaho up here. Just wherever you see that Trane logo, put the American Standard logo in your brain. I'm too lazy to make 2 presentations for each brand. Primarily, I'm covering Trane though, so I apologize to the guys in Idaho. So there's a lot of different stuff that goes into zoning, guys. Tonight we're going to cover some of the zoning application stuff, managing excess air. We're also going to be covering some of the manuals that are available, things that make it work, things that don't make it work, equipment selection, things like that. And then we're going to go into the Trane American Standard zoning and talk about setup, what's required, what you need to do to really make it sing for you. I have installed just about everybody else's zoning product at one point in my career or another. I will say that this is the closest to plug and play I've ever had quality zoning come. There are other zoning products that are easier to set up, but I wouldn't exactly call them quality products, having had experience with just about everybody's. So basically zoning is where we're restricting the capacity of a system to benefit a specific area of the home. So my question to you guys is, why in the world would we do that? Why zoning? What do you guys think? What is the point of doing zoning? This is the whole class participation part, guys.
Ethan, is to keep the house more comfortable.
Okay, so comfort.
Comfort. Heating, cooling your hot and cold spots.
Okay, so eliminate zones of discomfort.
Yep.
Okay, any others? One thing that's said a lot in these meetings is to save money. Does zoning save you money, guys? What do you think?
Yeah, I believe it saves money.
Okay. We'll talk about that a little bit tonight. Any other reasons we would zone a house?
For areas you don't use or not
Okay.
use much.
Okay.
Or if you have an undersized system.
Okay. I'll take both of those. Yeah.
Undersized ductwork.
That can be a double-edged sword there.
That
I would say.
Yeah, but that's what you see a lot of.
Yeah, we do see a lot of undersized ductwork out there.
Yeah.
Hey, Ethan, how about like when you have a cookie cutter home with a 2-story where they just put one system in and you're not pushing that air up to that second floor?
Mm-hmm.
That's where I could use a zone in a retrofit application.
Absolutely. Yeah, isolating areas to deliver higher quality airflow. Yeah, that can help a lot. Okay, so that's all good things. We're going to talk about, I think, just about every one of those today. But primarily, the root application for zoning is to make the house more comfortable. It's a comfort issue. So that's what the homeowner is going to get out of it. So have we ever come across zoning systems that don't deliver any of those things? You guys ever seen it out there? I know I have. Okay.
Yes,
If you have, why didn't they?
Systems over the years, Ethan, and some work and some don't. It just depends on layout of the system and if it was even sized right to begin with. And a lot of it's the old Honeywell stuff.
Okay. So sizing, you mentioned sizing.
Yeah.
Laying out systems properly is a big deal. Any other reasons why zoning systems don't end up working in the end, guys?
I have no idea.
Okay.
Too big equipment.
Okay, oversized equipment. So I'd say that those are the big three. Improperly designed, undersized, and oversized aspects are the big three of why these zoning systems don't work out there. So a zoning system takes all of the stuff that we're used to talking about, professing that we adhere to. We got manual J for load calculations, we got manual S for equipment selection, and we've got manual D for duct systems. If you guys if you've never read those manuals or you don't know what they are, I highly encourage you to investigate them in depth. They make great nightstand reading. If you're ever having a bout of insomnia, go ahead and open up manual D for about 20 minutes. You'll be out like a light. We have to wrap all of this stuff together in order to make a zoning system operate properly. In fact, they also have, in addition to manual J, we'll talk about manual ZR, which was released a number of years ago. But let's start with manual J. So why is manual J so important, guys?
Correct size equipment for the
Okay.
home.
Correctly sized equipment. When we say we're sizing equipment properly, we're sizing equipment to what's called a design condition over here in the green. And that is the point at which our building for air conditioning, for say, where our building cooling load lines up with our equipment cooling capacity. Okay, we can see that as the outdoor ambient temperature goes up, my capacity obviously goes down on my outdoor equipment, and my load goes up. So the point at which they crossed is what we call our design condition. So depending on where you are, there's different design conditions based on your local climate. Above that design condition, we can't cool the house. Below that design condition, anytime we're not right at design condition on a single stage piece of equipment, we end up having excess capacity. Okay. This is pretty familiar to everybody, but you know, that's kind of the double-edged sword. We got to make sure that we can keep them cool on the hottest day of the year, and we've got to make sure that that we have enough equipment. So this takes care of our sizing issue. However, this is not terribly friendly to zoning because this is the entire house's load. So if we're going to break up that equipment or break up that load into zones, is a single stage piece of equipment always going to work for us? What do you guys think?
No.
No. Now there are applications where you can do zoning with single stage equipment that we'll talk about. But a lot of times when we start talking about zoning, we need to be able to have multiple capacity equipment. So we could break this up into a 2-stage unit or a 3-stage unit, and we could have multiple design conditions. So we'd have our first stage design condition might be down here at, you know, say when it's 80 degrees outside. Our second design condition could be up around 85 or 88 degrees. And then our total design condition could be up here. So we could have 3 different design conditions that helps us accommodate our zoning. Because the old phrase about zoning is zoning's really easy until you close a damper. Because once we do that, now we have excess capacity that we have to deal with. So obviously we can stage it, or in the days of variable speed outdoor units, variable or modulating furnaces, variable speed compressors, we can actually break this into hundreds of different design conditions, if you will. So we could have our minimum compressor speed, have our minimum design condition all the way down here around 60, 70 degrees outdoor temperature, and we can match that load all the way up to our maximum design condition if we want. So equipment selection makes a big difference. You know, variable speed outdoor units for air conditioning have really brought zoning into what it wanted to be for the last 50 years. Everything else we've been kind of getting by, making do with what we had. But I'm a strong believer that the variable speed outdoor equipment has really brought zoning into what it should be. And so that's just kind of an example of different kinds of equipment we can do. We'll talk a little bit more about that in a little bit. But being able to match our design condition both for our total home and our individual zones becomes very important when we start talking about equipment selection, okay, which is next. So when we get into Manual S, which is our equipment selection part, these are some rules of thumb. So guys that are taking notes, take a picture of your screen, do whatever you want to do. But here's your rules of thumb with sizing equipment. So AC systems and heat pumps, you know, we talk about your single speed units should be a maximum oversized of 1.15, so 115%, and a minimum total load for 0.9. Okay, that's just normal stuff. Okay, once we get into 2-speed systems, we can max that out at 1.2, so 120% of our sized load, or a minimum of 0.9, so 90%. Once we go into variable speed, it actually allows us a little more on the maximum sizing of 1.3 because we have that variable speed outdoor unit. It allows us to fudge that a little bit. But you notice that the minimum size for everything zoning wise is going to be a 0.9 of the total load. That's for that hottest day of the year when all the zones are calling at once. We want to be able to deliver capacity. All right, so we don't undersize a whole lot. Once you get into the staged units and the variable speed units, you get a little more room fudge factor on the top end where you can oversize a little bit. Okay. Here's the big one down here, guys, though. To minimize excess air issues, zone damper systems shall have as little excess cooling capacity as possible when full cooling capacity is compared to the manual J block load. So when we say maximum, this is your upper limit. You don't want to be there. You'd much rather be down around 100% rather than being oversized, especially with zoning systems. Okay. Into that, we tie into our duct system as we talk about excess air. So excess air is where zoning lives or dies. So we talk about general rules. So here's your general rules for zoning. The first is rooms that are open to each other should be in the same zone. If you do not have a partition between rooms, like you see here, we've got a big living room. It's probably attached to a kitchen and a dining room of some variety. We'll show you an example house here in a minute that's got some common spaces. Common spaces should be tied to the same zone. If you have common spaces with multiple zones servicing them, you'll never be comfortable in them, period. With multi-story zones, each floor should be a zone or multiple zones. We start talking about thermoclines in a house, and temperature graduations in a house. Further up in the house you get, heat rises, guys, cooling falls. So we want to zone off our different floors. Okay. Unique rooms like detached rooms or rooms with large loads. We see this a lot down in New Mexico, where we'll have large rooms with giant glass vistas opened out to the south face of the valley or something like that. Somebody wants to look at the view. It's great. You got all that glass to look out. Those rooms we need to treat as individual zones as well. Okay. So here's the other rules. When we start talking about ductwork, each zone has to have a dedicated return. That return needs to be sized to handle all the air that is going to be put into that zone. So if you have a zone that's delivering 600 CFM when it's calling, you need to have 600 CFM of return. If you've only got 500 CFM of return, you're only going to get 500 CFM out of your supply because you will pressurize that zone. So make sure that we've got returns for each zone. Each zone sensor must be in the air path to the zone it controls. You'd think that would go without saying, but I've seen a lot of upstairs, downstairs zones where the thermostat for the upstairs zone is sitting in the hallway that's open to the downstairs zone. Okay, we need to have sensors in appropriate places. Lastly, never apply more zones than the equipment can handle. The reason for this is what happens when the smallest zone calls for the equipment to run. Okay, we have to take that into consideration. So while a lot of zonings will accept 5, 6, 7, 8 zones, okay, we've got to think about what happens when that small zone calls and it turns the equipment on. How much excess air are we going to have to deal with? We'll talk about that a lot here in just a second. We talk about air relief strategies. So we're gonna pull up a little zone here, or a little example home here, and we're gonna start with one that's easy, and we're gonna go through those 3 scenarios that were listed up there. So here's our little sample house here. We've marked windows. The red squares are supply runs. The blue squares that you see are returns. We've got a kitchen, dining room, living room, 3 bedrooms, master bedroom, 2 bathrooms, and a laundry room. Pretty simple layout. These we're getting roughly 120 CFM out of each vent in this case, and my load is 80,000 BTUs. My pen will work. And 3 tons. Okay, so there's my load on the house. How would you guys zone this? It can be zoned a number of different ways. Oh, I got to give you a north-south too. So that's someone give me a zone. What would you include in your first zone?
Master bedroom.
Okay.
Kitchen,
Everyone likes their
living
master bedroom to be on. Master bedroom.
And whatever.
Okay, so that's zone 1.
kitchen, living room,
Okay, I'm gonna pick up the dining room too.
yeah, and dining room. Yep, it's all in the
Okay.
same area.
We'll pick up the kitchen, living room, and dining room.
Can we do the laundry room as a voting zone, less than 25%?
Let's talk about that in a second.
Okay.
So let me go zone 2. Okay. So if we wanted to have this as its own zone, this only has one run, which is only going to give me 120 CFM on a 3-ton unit. Is that going to work out for us?
Probably not.
Okay. You'll also notice there's no door between the laundry room and the kitchen.
Well, then you better include it.
Okay, so let's tie it in with zone. Okay, so that leaves us 3 bedrooms.
With 1 duct each,
1 duct each.
so you should probably make it 1 zone for all 3.
Okay.
Agreed.
Okay, so we've broken this up into 3 zones. Now let's talk about equipment. So if I want to use, my first scenario was a single stage furnace and a single stage AC. Okay, what are my airflow requirements for those?
$115%. That
Come
right?
again?
100. Was 1.15
No, that's maximum sizing.
maximum CFM. Okay.
That's not anything to do with CFM. Let's say I've got a 3-ton AC and an 80,000 BTU furnace. How much air am I going to have to push for each piece of those equipment if I've got single stage units?
Oh, 15,000 BTUs.
Yep, or 80,000 BTUs.
Right. Oh yeah.
Well, the AC's got the larger airflow requirement. What's that going to be?
Well, actually, go on. That's fine. Go on.
1,200.
About 1,200. We'll use round numbers. And the furnace is going to be pretty close. Factory setting, I think, is 1150. Okay. So these being single stage units, can I close a zone on this thing and still have it work? And here's my biggest zone. This is my zone 2, this living room, kitchen, dining room, laundry room thing. I've got 1, 2, 3, 4, 5 runs there. Oh, 6. I picked up one in the kitchen here. So I've got 6 runs at 120 CFM apiece. How many CFM can I push in that zone?
720. It's around 720.
Yep, right around 720.
Yep.
So zone 2 is equal to 720 CFM. Zone 3, 330, or excuse me, 300. And I've got 3 in zone 2, zone 1 as well. That one's going to be 360 CFM as well. Okay. So my total CFM, I got 1080 plus 1360. I can push almost 1500 CFM for the whole system. But if I close zone 1 and zone 2 and just call in this living room, dining room zone, zone 2, what's my problem?
Too much static.
I got too much airflow. So we have an excess airflow problem. Because if we take 720 from 1200 CFM, we're left with 480 CFM. So I have to deal with that somehow. Okay, so single stage equipment's probably not a good answer because that's the biggest zone. If we call in one of these other zones, now I have, roughly a 840 CFM problem. Okay, that I got to deal with. So we want to minimize excess air. So single stage equipment probably ain't going to work out too well on this zoning plan. Okay, is there any way we could modify this zoning plan to make it work better with single stage equipment? What do you guys think?
Combine zone 3 and zone 1.
Okay, so combine the bedrooms and the master bedroom. That'd give us 720 CFM in that one and 720 in the front. So that's better. We've only got 480 CFM if we combine these two zones. When either of those two zones calls without the other one, we've only got a 480 CFM problem. So that probably could be dealt with. That's about a 30% excess air, 40% excess air. There are ways we could deal with that. Okay. I'll tell you guys where single stage equipment zoning works most of the time. And that's when your house isn't all one level, it's when your house is 2 levels. They do this up in Idaho a lot. They do it in northern Utah a lot, where you've got a house that has a full below grade basement that needs heat in the winter, but never needs cooling in the summer. And so they size the AC for the upstairs load only. And then they can do zone 1, zone 2. Okay. And then they size the furnace to take care of the whole house. Okay. But usually in this case, even though you've only got a single stage AC, we're going to run a 2-stage furnace so that we can split our capacity up and down. Okay. So let's go back to here. Let's disregard our single stage furnace. And let's go to his 2-stage unit. So if we went 2-stage furnace, 2-stage AC, my airflow requirements, now I've got 2 airflow settings. And my first airflow setting for first stage on that furnace is going to be around Larry and Keith can correct me if I'm wrong, but I want to say 820. And then my second stage is going to be the 1150. And my two-stage AC, we have a 30% turn down on the two-stage AC as well. And so that's going to be 800 and 1200 CFMs. Okay. Would a two-stage unit work better for this particular house? And if so, why?
Yes, because you can put it in low stage in the lower zones, the lower capacity zones.
Okay. Do you think I could run it in low stage with just a 360 CFM zone?
Yes,
Okay. We'd have to do something with our excess air.
With the
But-
modulating zoning, you could just open up a little damper and let some relief out.
Okay. So we'd have to use some type of relief strategy, whether it's a relief, bypass, a dump, something. We could probably make that work. It wouldn't be terribly ideal because anytime we're doing a dump or bypass, we're taking that efficiency factor and really flushing it down the toilet, or we're not saving them any money in that case. But I would venture to say that if you were to divide this house into two zones instead of three, a two-stage piece of equipment would work very well. Okay. Because in that two-stage furnace, we've got a blower that we're capable of turning down a little bit so that we would not have an excess air problem. So we wouldn't need a bypass and we wouldn't need a dump. Okay. But if we did this as a 2-zone rather than a 3-zone, I think we could make that work really well. Because then we got 2 zones that are going to make our minimum airflow requirements when either of them call. If we can get rid of excess air, we can make zoning work and work efficiently. Anytime we have an excess air problem, we've got to deal with it. That's usually going to cost us money in efficiency. Okay. So I'd say with a 2-stage piece of equipment, if we zone this, zone 1 and zone 3 together and zone 2 to get as it stands, we can make this work really, really well. Okay. So this drawing is getting a little messy, so let's pull out another one here. But if I really wanted to run this as a 3-stage or a 3-zone, excuse me. Let me redraw our zones here. And then we've got our zone 3 out here. Excuse me. Okay. And what did we say for airflow for these things? Back to my drawing here. We got 360 CFM. And this one was what? 720?
yep.
What kind of equipment could I put in this and let me do 3 zones without having excess air problems?
Variable speed condenser.
Okay.
Modulate.
Well, if I go to a variable speed AC, and someone said something about a furnace.
Modulating furnace.
Okay. What's my turn down in the modulating furnace? How low will it go?
I'm pretty sure the new ones do 50%.
Now we actually do a little better than that. We can get down to 40.
40, okay.
Minimum fire is 40% of total capacity.
Used to be 30.
Nope.
No.
The ACs will do 30. So the variable speed AC will do 30. Or if we wanted to do a heat pump, it'll do 25. Okay, so let's translate that into airflow numbers. So 80,000 BTU modulating furnace at 40% is going to need approximately, let's see here, 500 CFM. Okay, my variable speed AC at 25%. We'll call it a heat pump for rounded numbers. So 25% of 1200 is going to put me at 350. I think. Close. Yeah.
300, ain't it?
300.
Should
Oh
be.
yeah, it is 300 because 3 times 4 is. We'll call it 300 CFM. Thank you. I can math today. 30% would be about 330. So if I'm just running the AC, okay, what happens when my smallest zone calls? Do I have an excess air problem?
No.
No, I do not, because all my zones require at least 330 CFM. Okay. What about on my furnace? So my furnace, my modulating furnace, has a minimum airflow requirement of 500 CFM. What happens when my smallest zone calls?
You have excess.
I do have a little bit of excess there. So I'm going to have to manage my excess air in that case. That's not insurmountable though. I mean, that's only a 30% excess air for my zone size. So we could deal with that through one of our management strategies that we'll talk about in a little bit. Okay. Now, Mr. Thomas, I believe you mentioned that you would like, theoretically, put a door in here
Yeah.
and make this a separate zone. Find a different color here.
This is possible. I've read about this.
Wow, that did not show up as a different color at all. It's purple on my end, guys. So what if we did this one as zone 4? How could we make that work?
You can make that as a bypass zone or a relief zone.
Okay, so you could make this what we call a dump zone. Okay, so this is where we put our excess air. So when we've got excess air in zone 2 or zone 1, we're going to take that extra 140 CFM and dump it into the laundry room. Just so happens my laundry room will take about 120 without building any static. So that'll probably work. Okay, what risk do we run when we do that?
Overheating or overcooling that room.
We could overcool or overheat this room if we use it as a dump. Now there is a different type of dump zone that makes it intelligent. This is what we call a non-voting zone.
That's what I was talking. That's what I read about.
Okay, so we've got to have a pretty smart zoning system to let us do non-voting zones. But basically, non-voting zones will take advantage of any excess air that's available, but they don't have the ability to turn the equipment on. Okay, so if I've got a call for heat and zone 2 turns the equipment on and gives me some heating capacity and I've got some excess air, it'll open up zone 4 and say, give me all that excess air until it hits set point. And then it will close that zone back down. Then we're gonna have to do something else with the excess air at that point. But that would be one way to get that laundry room on its own zone. I actually have a colleague that has this exact floor plan, but he's added onto the house out here. And so he's made this all a non-voting zone. Works pretty well. Okay, so that's talking about equipment selection, making sure we've got enough ductwork to make a zone, and making sure we've got returns. So we mentioned that we have all of our returns in here. We've got a return in every bedroom, so we're able to return all 3 runs of that zone. I've got 3 supplies in the master bedroom. I have a giant return in there. And out in the main living area, we've got 2 very large returns returning that main living area. Now, if I were to make this zone 4, I would need to put some kind of return in there, which can get hairy when you've got a water heater in the room. So things to be aware of. So, anyway, so enough of that. We'll come back to our house a little later. Any questions about equipment selection, guys? There's a lot to think about when you're designing zone systems. It's not just, yeah, we can do that. Sure. You got to talk about ductwork. You got to talk about equipment. You got to talk about, how we want to strategize our zoning. Okay. So let's go back to our PowerPoint there. I will say, guys, that the variable speed AC and especially the heat pumps in combination with an air handler or a modulating furnace have really taken zoning and put it where it's wanted to be for the last 50 years. And now if we do it right, we can actually make them comfortable and save them a lot of money. Okay, so there's that zoning manual, guys. It's the manual ZR. It kind of takes all of this stuff and brings it all together for you. So I mentioned that zoning lives or dies by excess air. So what happens to our traditional systems when we restrict airflow, guys? There's a hint on the screen there for you.
Freezes up.
Freezes up if it's an AC. If it's a heat pump, it'll go out on high head. If it's a furnace, what happens?
Goes off on high limit.
Goes off on high limit, okay? So we've got to be able to manage airflow when we're talking about zoning, or we're gonna have equipment failures, okay? So how do we manage it? There's 3 principal strategies on how we manage excess air for zoning.
Dump
What's most
some.
popular, would you guys say?
The dump one.
Actually, it's not the dump one. What do you almost always see on a zoning system? It's usually
Have you
down in the mechanical room.
I've yet to see one, so I'm guessing here.
It's okay.
A relief.
They have what they call a bypass. So some sort of bypass where the furnace or air handler will take air off of the supply duct before the dampers and simply pass it through to the return duct. Okay. There's lots of different ways to do it. Some of them will have a managed bypass where it actually has a position sensitive motor. They can open it a little or a lot. Others will just have what's called a barometric bypass, which is a fancy damper with a weight on an arm that you can calibrate. Big quotation marks there, to manage your excess air. So bypass is probably the most common. Okay, so let's talk about bypass a little bit, guys. So what are some advantages of bypass? Why would you want to use a bypass?
Less negative pressure on the
Okay,
building.
you're relieving some pressure on the blower.
it. Avoid overheating, overcooling.
Okay.
This is Larry speaking up. It shortens your equipment life, so it's better sales.
Thank you, Larry. It does. It does shorten your equipment life. We'll show you why in a minute. Any others? What are some advantages of bypass?
Helps maintain airflow, lower static.
Does lower your static. There are systems where if you've just got a little bit of bypass, it might work out okay. Any big disadvantages to bypass you guys can think of?
Waste money.
Okay. They can be an efficiency loss, either through short cycling the equipment or not delivering capacity into the space.
Can it cause noise issues?
Yes, they can. Improperly applied bypasses can make your equipment very loud. Any others? We mentioned Larry. I think Larry's comment can be put into both categories of does shorten your equipment life. Has anybody ever seen a barometric bypass damper applied to a variable speed blower motor?
I don't even know what that is.
Okay, this is where we have a blower motor that is sensitive to static pressure. So it's going to hit its airflow target based on how much wattage it consumes. And a bypass damper will actually mess with that motor really badly. And I have seen zoning systems with variable speed blowers that eat a blower motor a year because it just wears the motor out.
So could you do a modulating damper in there as like a boating zone?
If there's a lot of hysteresis in that modulating damper, meaning it goes very slowly and it's not responding to static pressure, sometimes you can get away with that with a variable speed blower. Okay. Keith says, put the excess air somewhere useful, put it somewhere else, or throw it away. And bad idea about the variable speed blower. Okay, so there's some definite disadvantages to bypass. I'm going to show you guys my biggest pet peeve about bypasses. So this is a 3-ton system. Believe this is in cooling mode. Yes, it is. And so we have our return air in blue, our mixed return air in red, our supply temperature in green, and our temperature split at the house and our temperature split at the coil in purple and light blue respectively. Okay. So over here on the left, we have the system operating with my bypass damper closed. So at this point, the system is delivering full capacity for its stage. We've got good numbers, good supply and mixed supply are the same. We've got a 55-degree air temperature discharge, and we've got a 20-degree split, essentially, 19.9 degrees. Okay. Once we open the damper, and we call this first pass, second pass, third pass, fourth pass. If you'd like, you can think about this as intervals of 30 or seconds or 60 seconds, however you want to do it. Everybody does it differently. But on my first pass, you notice that my mixed air temperature drops because we open up that supply damper. It bypasses into my return, and so it mixes with my return. My return has now dropped to 68 degrees. Okay. This in turn drops my supply temperature to 51. My temperature split at the house, so at the register, is 24 degrees now, but my temperature split across the coil is 17. Okay, and this trend continues. Second pass, We're even lower on our return. We're even lower on our supply. My temp split at the coil just keeps dropping, guys. Okay. This is the smoking gun here, though. This temperature split at the coil keeps dropping on us. So this is an indication that we are actually losing capacity out of our indoor coil. The colder air you bring into that coil, the less it's able to absorb in terms of heat from the house. Okay. Once we're starting to see these discharge air temperatures drop along with it, we start worrying about maybe causing an issue with freezing in the future. Okay. This particular system, a 36% bypass, is the maximum that it will still operate under. Okay. When I ran the numbers for this system, so this is a 3-ton AC. Okay. I can't remember what my percentage of bypass it was, but there you go. Now, if we take that and we close 2 zones on that system, we go to a 64% bypass. You can see what's happening to my numbers. It's just more dramatic. Okay, starting to get a discharge air temperature of 42 degrees. What do you think that coil temperature is if my discharge air is at 42?
Mid-30s?
I'd probably say high 20s. Okay, because I'm mid 30s over here. My coil temperature is probably around 35, 36 degrees when I'm getting a 55-degree discharge. So I'm freezing the coil now. You can see that my capacity for my indoor coil is steadily dropping. I'm only getting a 13-degree split across the indoor coil, but I'm delivering a 32-degree split at the registers because of that mixed air. Because at the register, we're still pulling in 75-degree air, but we're discharging 56.3, or excuse me, we're discharging 42-degree air. Okay. So this reduction in coil capacity also translates directly to an efficiency loss. So the SEER rating of my equipment is plummeting as my reduction in indoor coil capacity goes down. Eventually, this thing's either going to freeze up and go out on a low pressure switch or something like that, or it's going to be cycling on a freeze stat if somebody installed a freeze stat, or a discharge air temperature limit. Okay, we'll talk about those when we talk about setup, but this thing's going to cycle off. It's going to cycle off for 5 minutes probably if it's a traditional zoning system. It'll cycle back on, it'll start cooling. 4th pass rolls around again. We're going to cycle off again. I actually worked on a zoning system that unfortunately my company installed that operated just like this. That thing had more off time than it had operating time. It took 3.5 minutes to trip the discharge air temperature sensor, and it had a 5-minute off cycle. Needless to say, the 2nd floor was very warm. Okay, so when we start talking about bypass, we start having to worry about this. So let's look at a heating system, guys. So now we're into my furnace. Okay, we got my return temperature. This is actually a mixed return. And we have the supply temperature and the temperature rise. So with my bypass closed, we start cranking. This is an 18% bypass. This is as large of a bypass as this system would tolerate. This is an 80,000 BTU furnace. That 18% bypass, you can see what happens to my temperature split, guys. I get up around 58 degrees, which is going to be right up against the upper limit for a temperature rise across most furnaces. Okay, I've gone from 119-degree discharge temperature to 129. You can see that my return air temperature is also getting up towards the upper limit on what my furnace will tolerate as well. Okay. Most furnaces are only going to tolerate up to an 85-degree return. Okay. So we start to see that. What do you guys think that that's doing to that heat exchanger, though? Is it doing me any favors? that thing doing any favors to my my heat exchanger?
No, not at all.
No, it's gonna hurt that heat exchanger. Not as bad as this though. So now we close that second zone. Now I'm at a 43% bypass. You think my furnace is gonna operate very long at an 82-degree temperature rise across it?
No.
No, no way.
Absolutely not. I'm hitting the limit. Okay. So this furnace is going to cycle on the limit. Eventually the limit will wear out. And eventually the heat exchanger will wear out. Okay. There are some statistics out there that zoning systems with bypass dampers, even properly applied ones, will have anywhere from a 15 to 30% reduction in lifespan on the furnace. Okay, and that's with a properly adjusted bypass. So bypass has its place, but it's going to have some negative effects. Okay. So this is taken straight from a zoning manual, guys. They talk about that. This is their example on a 4-ton system at 1600 CFM. The smallest zone that it's designed to handle is a 400 CFM zone. So that's a 25% zone. So they tell you that your bypass must be able to handle 1200 CFM. Okay. I'm doing this to my furnace with a 43% bypass. What am I going to do with a 75% bypass? This is out of a zoning manual, guys. This is an OEM zoning system. Okay. Is this good advice?
Doesn't look like it.
This is terrible advice. Don't listen to this crap. Okay. I have found that if your bypass calculation comes out that you're going to have to bypass more than 30% of your zone, of your capacity, you're going to have problems. That's just my field experience. That's not written anywhere. That's just what I've noticed. Okay. If you're going to have to bypass more than 30%, you're going to have problems. Sometimes you're going to have problems if you have to bypass 30%. Okay. It all kind of depends on your system. But yeah, to have an OEM zoning system tell you that you need to have a 75% bypass capacity, what are we doing? Okay. So hopefully we're dispelling some of those myths. This isn't an actual zoning system, guys. That's the bypass duct. That is a 16-inch bypass. What do you think is going to happen to that thing?
So getting short circuited.
It's going to short cycle in cooling. It's going to short cycle in heat. I mean, this is an electric air handler, guys. This thing's they're probably going to throw a 20 kW heater in here. Needs, 1800 CFM on a 16-inch bypass. Thing's going to melt down. Okay. So bypass, in my opinion, generally a bad idea, but it does solve some problems in very unique situations. You can make it work. If you ever have to set a barometric bypass in the field, highly encourage you to educate yourself on how to do that properly. It will involve a manometer. Hopefully this got torn out before they finished it. Okay. Let's talk about energy savings on systems. Okay. So we talked about, zoning can be an energy saver. Okay. In special circumstances, in well-designed zoning systems, I would agree with you. Okay. Here's the thing. There are study after study after study that talks about setbacks and saving you money. Okay. We've all seen the factory programming in those thermostats that says the energy-wise programming. They have like an 8-degree setback for, 9 hours during the afternoon. And then they have it come on right before you come home again. Guys, I hate to burst everybody's bubble, but a short setback, basically anything less than a day at the least 16 hours, any setback that's shorter than that is not going to save money. Okay. where I think Mr. Thomas mentioned a application where we had an area of the house that didn't get used. You know, that could help you with your zoning. That would save you money. Okay. But zoning for setbacks probably isn't going to save you a whole lot of money. In fact, it may actually increase your energy usage because now your equipment's going to have to run longer, harder, and usually in the time of the day where it's costs the most to run. Okay. So here's what it does for your energy bills. Remember, we talked about that that capacity of our indoor coil going down as my bypass was running. Okay, so here's my efficiencies. I got a 10 SEER system with that bypass closed, or a 10 EER, excuse me, not SEER, EER. My 10 EER with the bypass closed, 36% bypass, it drops to 9.7. 64% bypass, it drops to 8.5 EER on a 4-ton AC, single stage unit. Okay, so is that bypass saving me any money? Absolutely not. Okay, it's costing me money to run that bypass because I'm lowering the capacity of my equipment, but I'm pumping the same amount of electricity or possibly more into it. Okay. So one of the ways that we can actually apply zoning and make it save us money, and this is one of our excess air relief strategies that I like to use, is with the OEM zonings, a lot of times when they're integrated, you can actually reduce the airflow. Okay. Most air conditioners, believe it or not, will tolerate up to 30% reduction in airflow and still work. Okay. And we're able to do this with an integrated zoning system. Okay. It creates a similar effect to bypass where we don't have an excess air problem anymore, but we can do it with some energy savings. Okay. The trick is you got to have that integrated blower with the zoning system. So here's, oh, I thought I had a sheet here. Hang on one second. I accidentally hid my slide. So here's an example of a blower. Okay, so we've got a 1985 CFM at a 0.7 static is going to consume 824 watts. Okay, now if I can do a 30% reduction on that blower, so I'm going to cut my CFM by 30%. That takes me to 1391. It also drops my static to 0.3 when I do that. And look at what my blower is doing now. Okay. I'm using less than 300 watts at 1300 CFM. So I've solved my excess air problem. And I have, sorry guys, I didn't realize that wasn't coming up for you. There we go. I got something going on here. Sorry guys. Try this one more time. There we go. Come on. There we go. So we can take that 1985 CFM, drop it 30% to 1391, and my blower usage goes from 824 watts to less than 300 watts. Okay. So now I've managed my excess air problem. And I've managed to save 60% power. I got 60% power savings, maybe a little less. Okay. So now I'm managing my excess air and I'm running efficiently. This does not cause me to lose capacity on my equipment at all, or or lose efficiency on the equipment. So that's one way we can do it. We can reduce the amount of air that we're putting into the system. So where we mentioned earlier, where we had this example of needing, on my two-stage unit, needing 800 CFM, okay, but we have only got 720 CFM capacity. We can simply turn that blower down to 720 CFM without having to sacrifice the efficiency of the equipment and without having to have a bypass or any kind of relief strategy. We just reduce the blower speed. That's one way to do it, guys. Any questions?
Then what happens when the homeowners call you back because they have no airflow?
So most homeowners are not going to notice a 30% reduction
Okay.
because we're doing that so that we don't blow the curtains straight up to the ceiling.
Okay.
So that keeps our static low. So they'll actually probably be happier because they won't have as much register noise. It also keeps the equipment running, which keeps you from having to come back.
Okay.
Good question.
So does that also work with a heat pump?
It does. So we can do that with a heat pump. I want to say to a slightly lesser degree. I don't think we get quite 30% turn down. I'd have to actually look that up though.
All right, well, then I'll contact you tomorrow.
Yeah. I'll make a note to myself. What other questions do you have, guys? Okay. So we've been going for a little over an hour here, so I'm going to give you guys a 10-minute break. Get up, get a drink, get some dinner, do whatever you need to do. And we will be back here at, let's call it 25 after. And we'll get going again. All righty, guys. So let's pop back in here. Let's talk about some other ways to do excess air management. So we're gonna pull up our trusty house again here. So we're gonna do some excess air management. We're not gonna worry too much about we'll go back to our 3-zone configuration here. By the way, some of you may notice a severe lack of a return or a supply in that bathroom, I should say. Turns out when you do the load on an interior bathroom, you can usually heat and cool it with a 3/8 inch piece of tubing. What exhaust fans are for. Forgot my zone 3 here. Okay, so let's start talking about different types of relief. So we talked about bypass, we talked about dumps or relief. We talked about dumps or airflow reduction. And their advantages and disadvantages. So that airflow reduction works really well, but it only goes so far. So let's talk about what we call intelligent relief strategies. And so we've got our zone 1 has a 720 CFM. My zone 2 is the 330. And zone 3 is 330. Okay. So let's say I'm working on a piece of equipment that has a minimum heating CFM. So heating stage 1 has a minimum heating CFM of 500 CFM. Okay. And so if my zone, let's call it zone 3 is calling, how much excess air do I have to manage?
$170.
So I got 170 CFM I've got to deal with. Okay. So I got 170 CFM. So we can run a bypass. It's a gas furnace, so we can't really turn the blower down too much. Can a little bit, but not a whole lot. So we want to put this somewhere where it's going to A, not cost us any more to run. So the bypass is out. And we also want to manage that excess air so we don't put excessive wear and tear on our equipment. Because even if we didn't do anything with that 100 CFM, that zone would probably run, the system would run hot, which would cause extra wear and tear on my furnace. So we want to eliminate that as well. So what we can do is we can do something called intelligent relief. And where this comes into play is we can do, we can have a zoning system that calculates a load for each zone. So we can get an intelligent zoning system that knows that my zone 1 is capable of carrying 50% say of my system capacity. My zone 2 is capable of carrying roughly 35% of my system capacity, and my zone 3 is capable of carrying roughly 35% of my system capacity. Okay. So now my zoning system knows what sizes each zone is. Okay. The other thing we can do is, rather than using a conventional thermostat, which is really just a glorified on-off switch, we can use what's called a PI control. So PI controls take two numbers. The P stands for proportional, which I can't spell. Okay, which is really just a fancy word for delta T from your set point. So this is how far out of set point you are. And the I stands for integral, which I ironically can spell, which is really just saying how much time from set point you have been. Okay, and it takes these two numbers and generates a number called load value. Okay, and so that load value number can give us basically how strongly a zone is calling. Okay, so this load value number can help us out with our relief strategy, because now we can take a look at our zones and we can say zone 3 is the zone that's calling, and it's calling for first stage, which would be a load value of 100. Okay. But I've got a 170 CFM excess air problem. So let's go out to my other zones and see what their situation is at. So we can look at the load value for zone 2. We look at that one, let's say it reads 0. And we can look at the load value for zone 1 and say it's maybe 75. So it hasn't reached 100 yet, so it hasn't called for the equipment, but my system can see that I've got a zone that's creeping up to the point where it's going to need to get some heat into that zone. And so what we can do is what's called intelligent relief. This pairs up with modulating dampers. So we have power open, power closed dampers so that we can control the position of them. And we're able to actually take this damper and open it to its minimum position, which would be 25% open. Okay, which will then take my extra 170 CFM and put it into zone 1. So we take my 170 and we're able to relieve it into zone 1. So now we're taking that excess air that would just be wasted energy with any other relief strategy, and we're putting it where it's going to be useful. So we're going to, obviously 170 CFM in a 720 CFM zone is a drop in the bucket. Okay. It's not going to do a ton to influence the zone. It will do a little bit. But at the same time, we're not wasting that energy that we've paid for. Okay. Now, if it comes to the point where zone 3 is still calling and my load value goes to 0 because we've been dumping some heat in there. Okay. Now my intelligent release strategy is going to look to see which mode the zones are in. So if zone 2 isn't calling because it's in cooling mode, but zone 1, even though it's not calling, it's in heat, it's going to say, okay, now I'm going to take my excess air and I'm going to put it into any zone that's in the heating mode. Okay. So even though I don't have load value anymore, I've satisfied my load value, it's still the prime candidate for intelligent relief because it's in the heating zone. Now, if my mode in zone 2 were in heat, it would actually split that 170 CFM between both zones 1 and zone 2. So it would start to relieve into both of these zones. Okay. If we still had an excess air problem after opening both of these zones to 100%, and I know it doesn't work out in this example, but say, I had this little tiny zone that was calling for heat and I had a single stage piece of equipment. It's got a crap load of air to get rid of. If it gets all the zones that are in the heating mode opened up all the way, it will then go out and start to relieve into zones that are in a cooling mode or off at that point. So that's kind of the last ditch effort. If we ever get to that point in our zoning system design, we've done something terribly wrong. Okay. But this is just kind of an example of how that intelligent relief works. So it prioritizes relief air in 3 steps. Those priorities are to zones with load value, then zones in like mode, and then zones in all modes. Like I said, very rarely do we get here. We almost never get here if we've done our job right. Okay. in order to get here, we're going to have to open all the zones with load value to 100% and still have excess air problems. I have seen this happen. Okay. Where this happens is where guys try to put too many zones on too small of a system. And while a lot of these intelligent zoning systems will handle 8 zones, I'm going to tell you right here, right now, today, guys, it's a bad idea. Even if you've got a 5-ton unit, an 8-zone system is going to have a lot of problems. It's going to require a lot of tuning if it ever works at all. Okay. I would advise most people doing zoning maximum of 4 zones. Okay. Because once you start getting over 4 zones, you're almost guaranteed to have non-voting zones at that point. Your zones are getting really small. It starts to create lots of excess air problems, and your relief strategy is going crazy trying to compensate for you. But it's gonna struggle. Okay. So that's what we're talking about when we talk about intelligent relief. What questions do you guys have about that? Because it's a little vague. So everybody's relief, intelligent relief experts now, right?
I've seen it on Nexia. When you log into Nexia on a zoning system, you can watch the dampers move and see it in real time if the homeowner's logged into the system.
Yep.
And we all have the AUID numbers on there, and it's actually pretty neat the way it works.
Yeah. I'll actually pull up some examples a little later this evening of that. But yeah, it's really slick. It allows you to manage that excess air without neutering your equipment, lets you manage that excess air without costing the homeowner extra money. So where this really, really comes into play, guys, and where we can really manage our relief really, really well is I can take that same zoning system and if I put a variable speed outdoor unit and or a modulating furnace on this thing, I can match anything that happens. So if my zone 1 over here needs 330 CFM, my 3-ton AC that I've got on that has a 25% turn down. Okay. I can turn that unit down to where it will exactly match the capacity of that zone. I have no excess air problem at that point, guys. Okay. If my zone 2 turns on while zone 1 is running and it needs another 330 CFM, my outdoor unit will go from 25% up to 50%. And it will give me 660 CFM. No excess air problem. I add my zone 3 to that, and 720 CFM plus 660 CFM is obviously more than the capacity of my outdoor unit. So it's going to take that whole system up to 100% at that point, deliver air everywhere. But then if my zone 2 drops off or my zone 1 drops off, it'll simply take me back down to about 60% and continue to run without any excess air. Okay. So zoning for me used to be a where do I want to bleed question. I used to dread doing zoning because it was always a question of how much is it going to hurt? I used to bid $1,000 into a 4-zone system just for callbacks and tuning. Okay. We used to put $1,000 into those systems just to accommodate our callback cost. Because they took a lot of fine tuning, a lot of tweaking just to make them work right. Now, guys, with variable speed outdoor equipment, with modulating furnaces, I mean, I put a modulating furnace into this place, I can run that 25% zone and it'll just intelligent relief that extra 15% of air into whichever zone's calling next. Okay. Makes it really easy to get zoning right. But it also makes it really easy to shoot yourself in the foot. And the thing I see guys do the most that shoots them into that foot is they try to go zone 1, zone 2, zone 3, zone 4, zone 5, and zone 6. And I have seen guys zone a bathroom. 8x8 bathroom. It's on its own zone. Okay. That's where it all falls apart when we try to do too much. Okay. So zoning can do a lot of good things for you guys. Integrated zoning with modulating capacity equipment can make zoning sing for you. Okay. But if you got to do the homework, you got to make sure the ductwork's there. You got to make sure the return's there. You got to make sure you've got all of that segmented out properly. Otherwise, you start to have problems. Okay. So, in case you guys were wondering, this is my house. This is my house right here. This is my zoning strategy. I run 3 zones in this house, or will run 3 zones in this house. My family gets around with okay. I'm gonna have my kitchen, laundry room, living room, and dining room. I'm gonna have my 3 south-facing bedrooms, and I'm gonna have my master bedroom. This is why I've got 3 runs in this master bedroom. When I reducted the house about 8 years ago, it was a crawl space, so I had that luxury. I knew I was going to put zoning in, so I made sure my master bedroom had a little extra air so that I could run it as its own zone and not have an excess air problem. So especially if you're building from scratch, you can accommodate those things. Okay. I ran 7-inch ductwork instead of 6-inch ductwork to help accommodate my zoning in the future. Now, if you're going out on retrofits, you got to pay a little more close attention to their zoning. How are you going to zone it? Okay. What can you do to zone it? And you may be a little limited there. But if you do it right, guys, you use the right equipment, you use the right plan, that zoning system will really work well. If you don't do the homework and you don't do the research, it'll bite you in the butt every single time. Okay. So that being said, any questions about design, setup, or excuse me, design, equipment selection, relief strategies, any of this stuff we've covered up to so far? Larry? Oh, I thought your hand was up. Any questions, guys?
No, I'm good. I didn't put my hand up, so.
I thought it was just my icon on accident.
Okay.
Anyone else?
Good class, Ethan. I learned a lot.
Oh, we're not done yet.
Okay.
Now we get to play with Trane zoning and American Standard zoning. Any questions up to this point, though?
I just have a question about turning down, but I consider talk to you offside from this class.
Okay, that's fine. All righty, so let's keep going here. Pull up another presentation. Oop. Doesn't want to play nice for me for some reason. Bear with me here, guys. All righty. Okay, so we got to play on the worksheet here. So number one, guys, when we're designing zoning systems, you got to talk to the homeowner. Make sure that they understand what they're going to get. Make sure that their expectations are realistic. Sometimes you got to take that homeowner down a notch or two. Okay. They want that 8x8 laundry room on its own zone. They need to understand what that's going to do, what you're going to have to do to accommodate that. Okay. What would you guys say is the next most important thing?
Your square footage for each zone
Okay.
for CFMs.
Separating out your zones, your CFM, what goes along with that? You got to know your load, right?
Okay.
You got to make sure that your CFM is going to match your load for each zone. So doing your research on your ductwork, your load, what else? What comes after that?
How well the house is insulated.
Okay, that's going to factor into your load for sure. Once you know your load and your airflow capacities, what can then you then decide?
How big of a unit you need.
Yeah, you start getting into equipment selection. How big? How many stages? Yeah, stuff like that. Okay. The point is, guys, start with the homeowner. Make sure they understand what's possible, what's not possible, and then do the work. You got to do the work. The guys I talk to on a regular basis that have problems with the zoning systems don't do the work. They just try and wing it. You got to go through, make sure your stuff conforms. Do that load, do that duct. Okay. And then select your equipment. Okay. Once you've got that all done, then we need to combine zones. It can kind of go into the upfront part, making sure that you look at that smallest zone and make sure that you have a strategy to manage that excess air. Okay. And then at the end, you got to circle back to that homeowner and make sure that they understand how the system works, what to expect out of it, what its limitations are. I have a customer that I've been working with, a contractor on for upwards of 2 years, that thinks that because she sets her master bedroom to 65 degrees, she can then set her living room, which shares a wall with the master bedroom, to 75 degrees and have them be at set point all the time. Okay. Is that a realistic expectation out of a zoning system? No, not really. Maybe if that master bedroom was on a separate structure or had, a 20-inch piece of insulation between the living room, we could get that kind of temperature gradient out of the zoning system. But, we've got to talk about realistic expectations, understand how the zoning system works. It's not made to give you dramatic temperature shifts through the house. It's made to make each area as comfortable as possible. Okay. So that being said, guys, here's a look at the Trane and American Standard zoning systems. This is straight out of the installation guide, page 1. So this is the zone panel. It is not made by Honeywell, contrary to popular belief. This is a Trane American Standard product through and through. Your zoning system, your zoning panel comes with a discharge air temperature sensor, which is required. You also have a static pressure sensor and a couple pitot tubes. They give you some tubing. They give you these little weird jobbies that we'll talk about in a minute. and they give you housing for that static pressure sensor and a bunch of screws that are pretty useless. You use your own screws. I don't know anyone that's screwing Phillips head screws into ductwork anymore. They give you all kinds of wiring diagrams in there. This would be for a fully communicating unit. So this would be a communicating indoor unit, communicating outdoor unit. We're going to have RD and B from the thermostat to the indoor equipment. And we're going to have data in common only from the indoor unit up to the zone panel. We do not bring R from the indoor equipment to the zone panel. The zone panel is powered independently from your field supplied 24-volt transformer. That transformer is going to power the zone panel, all your extra zone sensors, your dampers, and anything else you apply to this zoning system. Okay, so very important that you have a 24-volt transformer when you show up on your job site to install these things. We can tie in a second zone panel if you've got to go over and above 4 zones. We use power open, power closed dampers. We'll talk about those more in a second. We've got a variety of sensors. We have the non-communicating temperature thermistors, which we affectionately refer to as RATs, remote air temperature sensor. Or we can have a communicating display style thermostat that previously was the 940s. Now it's the 1040s. Okay. We're going to have your discharge air sensor and your static pressure sensor as well. So that's on a communicating outdoor unit. There are options to put a relay panel to put it to a 24-volt indoor unit. The requirement for this zoning system, though, is that we do have to be able to talk to the blower motor directly. So when you apply this to a relay panel, you also have to make sure that your indoor equipment is a Trane or American Standard indoor piece of equipment with a variable speed blower only. Okay, no PSC blowers, no X13 motors. It's got to be a variable speed blower. The way that you can tell that is if your furnace has a BK terminal on it or your air handler has a BK wire in it, you can use the zoning system. But it's got to be Trane or American Standard variable speed blower. So this is just a close-up of all of our wiring connections. So in here you see your data and your common from your indoor unit or your relay panel, whichever the case may be. We've got our data and common if we've got a communicating outdoor unit. This is where we're going to hook up all our communicating zone sensors if we have them. Now these terminals will usually only accommodate 2 pieces of 16 gauge wire or 18 gauge wire. So they give you these little guys. Let me flip my camera over here. Show you these clamps that they give you in the kit. So these are the clamp style connectors. You can see it's got positions for up to 5 wires in there. The way these work is you take all of those connections to the open position, which is at 90 degrees. You will insert your wire and then slap it down. Those will clamp all those wires together. That gives you a nice firm connection if you've got to do more than 2 wires in that wiring terminal. So you can run a pigtail from the wiring terminal up to this and then get up to 4 more connections with this. The reason we like these is they put a nice positive clamp on each wire. You're not trying to shove them all into a wire nut and hope you get a good connection, especially when we're dealing with data transmission. All right, so there'll be 3 of those in your box that come along with the zoning system. Okay, so those are going to connect there. Then you've got your transformer connection. Your static pressure sensor ties in right here in the top right. It is color coded to the color of the wires that come out of the static pressure sensor. Below that, you've got your discharge air temperature sensor, which I mentioned is required for the system, does have to be installed. We do have an optional return air or a mixed air sensor if you're doing something that you need those readings for. And then we've got our non-communicating zone sensors. So these would be the 2 wire thermistors, affectionately referred to as the RATs. Up on the left-hand side, we've got positions for all of your dampers. So we have our common wire, our power open, and our power closed terminals right there. So you're going to wire up those dampers right there. 3 wires. Not what I wanted to do. The comm light on this. Anybody know what the comm light does?
Lets you know that it's communicating.
Okay, lets you know that it's communicating, and it will actually give you a device count based on how many blinks. It will tell you how many communicating devices it sees. So if you're running a communicating furnace, communicating outdoor unit, and 3 communicating out zone sensors, plus your zone panel, it's going to blink 6 times at you. If you're just running rats in a 24-volt relay panel, it's going to blink twice at you. 1 for the zone panel, 1 for your 1050 control. That's going to be your communicating sensor. Okay. When we're talking about where to put these things, guys, they want your pitot tube for your supply static, a minimum of 6 inches off the top of the air handler. I would tell you to go as far as you can. You do want to be located in the ductwork, as close to the center of the ductwork as you can be. That eliminates turbulence. And then we want our discharge sensor at least 2 inches away from the static pressure sensor. Orientation on this is important. You'll notice
Turn
it's
the
got a
TV
piece
on.
of
I'll
C
just watch
channel
it.
right here. And the sensor actually sticks through the other side of that
Oh,
C
I have the
channel.
TV.
So
Oh, hang
there's
on, look
an
at
up
this. I
and a
got a
down
computer, I got a TV, I got a
on this
phone, I got
guy.
a tablet.
So be aware of that, guys, that make sure that that discharge sensor is oriented properly. Okay. On our return side, we want to be a minimum of 6 inches away from our filtration. Okay. And so we are measuring the total external static or duct static. Excuse me, the duct static on this application, and the controls will actually, the zoning controls will use that to calculate our zone sizes based on our duct static. So that's why we use duct static rather than blower static. Okay. It is important when you're looking at positioning those pitot tubes that you get them out of any areas of turbulence. So when you're near fittings, you want to be downstream. The general rule of thumb is you want to be 2 duct sizes downstream of any fitting or directional change in your ductwork. Of course, not all fittings are created equal, as you can see here. Swept fittings have a lower zone of turbulence versus a hard elbow fitting. Okay, so make sure when you're putting your pitot tubes, it'd be much better to put your pitot tube over here than over here. Same thing over here. Of course, you could probably put it there and be okay. It's important to get those pitot tubes in places of low turbulence so that we can get good static pressure readings. There's a nice close-up view of that static pressure sensor. It is polarity sensitive. You'll notice on the front of it, it says low or negative. That's going to go to our return pitot tube. Our supply pitot tube is going to go into the back of it. Okay. So our discharge air sensor, like I said, is required. If you don't put that discharge air sensor on, it doesn't work. And we can actually see that discharge air temperature sensor in the Nexia diagnostic screens. I have more than once pulled up zoning systems to help guys with them and seen that discharge air temperature read the ambient in the mechanical room. So we can tell if you take the discharge air temperature sensor out of the ductwork to keep it from tripping on the discharge air limit. Okay. The static pressure sensor is a 5-volt DC device. So anybody who's had experience with 5-volt devices knows that you do not run those wires in bundles with other wires. Anyone tell me why?
Picks up interference.
Okay.
Nate, why don't you go first?
Picks up interference.
Okay, it's going to pick up interference from the current running through the other wires. Absolutely. Okay, so when you're running that static pressure sensor, make sure that you run it separately. It's not strictly required that you use the static pressure sensor. You can set it up manually. However, I will tell you guys, if you can, use that static pressure sensor. It makes your life so much easier. Takes all the tuning out of this thing. Okay. We noticed that the R is not included in the indoor or relay panel terminals. That's because we don't want to cross the voltages between our supplied transformer for the zoning system and our transformer in the furnace. We don't want those two to touch each other. Don't try and use the furnace transformer to run the whole zoning system. We run into a lot of random error syndrome systems when we do that, because the zoning system generally has a much higher VA requirement than your furnace can supply and power the furnace at the same time. So we end up with dropped communication, we end up with dropped sensors, dampers that don't fully actuate, they're running at lower speeds. So it's just bad juju. Make sure you guys are sizing your transformer properly. You can see here, we've got some cheat sheets here where we've got our VA ratings for everything. I will tell you guys, when you look at that minimum transformer size, where we've calculated out 2 zone panels, 12 dampers, and 8 communicating sensors, that minimum VA rating, I'm going to tell you to multiply it by 30% just so you're cushioned. Okay, so if you come up with a 24, I want to see at least a 35 VA transformer in there. I will tell you that 35 VA transformer will power most of these zoning systems. So if you just go and pick up a second furnace transformer, that'll generally do everything you need it to. Obviously, if you're using somebody else's dampers, you want to check out the VA rating on those. I know that the carrier dampers, I think, are 2.25 VA. And some of the Lennox dampers, or excuse me, some of the Honeywell dampers are even higher than that. So make sure that you're making your power rating when you supply that transformer. I did mention that you can use other brands of dampers. It defaults to a 60-second travel damper. That's the time that it takes to go from fully open to fully closed. You can adjust that damper timing to use other dampers. There's some carrier systems out there that use 15-second dampers. As long as that is somewhere between 15 and 60 seconds and all the dampers are the same, you can use that third-party damper. You may just have to adjust that timing. Up to 4 dampers can be used. Those are the Trane dampers, obviously. If you use somebody else's, the VA rating maximum for each damper control is 6 VA. So we can use up to four dampers per zone. And I thought I had a diagram here. I do. So we'll get back to that. There's kind of a picture of all the Trane zoning dampers. They come in various styles. We've got the rectangular frame dampers. You can get those in side or bottom mount motors. We have the round build-up dampers. They're already built into the housing. You just attach your ductwork to them. And then these are actually my personal favorite, which are the round retrofit dampers. So this is what I'm using on my system. Because all my ductwork's already installed, I can get an appropriately sized damper, cut a slot in it, and then this is fully gasketed, so you don't have any air leakage or anything like that. You just slide it in, center up your damper, and you're good to go. There's just a picture of that damper being wired up. If you're using 18 gauge wire, the longest you can run is 150 feet. Then we start to get signal degradation. If you want to go further than that, we're going to start talking about 16 or 14 gauge wire. I've never run into a system that's got a damper 300 feet of wire away from the zoning, the furnace. So usually they're pretty close. So we mentioned up to 4 dampers, you just wire them in parallel. If you need to go to go above 4 dampers, that's an example of what you can do. You just need to put in some isolation relays. Make sure that you're powering them off so that when it goes to power the damper closed, it's going to hit that relay on relay 1, and it's going to close that set of contacts and power open all of your dampers at once. So as many dampers as you want. I have had a zoning system that I worked with a guy on that had 16 dampers on one zone. So it is possible. Just got to make sure your relays are sized for it, and we need to isolate them so that we don't burn up the relays in the zoning board. Okay. The rats we talked about are just 2 wire rats. This is a little thermistor. This is about a 1-inch square white box that you mount to the wall. 2 wires, and they just wire up to your zone panel. Not polarity sensitive. If you're putting in that second zone panel, so you've gone contrary to my advice and gone into more than 4 zones, there is a switch in the top right or top left-hand corner of that zone panel to switch it from zones 1 through 4 to 5 through 8. It is important that you do that and pick the right panel. Okay. So zoning setup. So once you've got everything wired up and you're ready to start setting up your zoning system, I'm actually going to swallow my words right here. Let's take a 5-minute break, guys. Go use the restroom, get another drink. Let's come back and we'll go through zoning setup and then get you guys out of here, okay? Anybody who didn't make it back from break, raise their hand. Okay, any questions before we jump into setup, guys? Aaron's not back yet, but he's present enough to raise his hand. Oh, come on. So let's jump into zoning setup. So zoning setup is done on these zoning system through the 1050 thermostat. So you must have a 1050 thermostat in order to run the zoning on this thing because it houses all the brains. Older systems, you may see the older 950 running this. It is the brains of the operation. It's a scary prospect indeed. Okay. So as part of the installer setup, if you've wired your zone panel up properly and it's talking to your 1050, you will get the last option in that equipment setup screen is going to be whether you want to enable or disable zoning. You can hit enable. Couple things to be aware of. If you're using a variable speed blower that's not a communicating system, or even if it is, you must adjust your CFM per ton cooling or heat pump to 400 CFM per ton. Factory is 350. So please make sure that you are doing that. Make sure you're getting your CFM per ton in both AC and heat pump modes set to 400. That is very important. Okay. So once you enable zoning, it will launch you into the zoning setup. First thing it's going to ask you is your zoning damper travel time. So defaults to 60. If you're using carriers, set it to 15. Just make sure that all your dampers have the same timing guides. After that, it wants to know if you want to auto detect dampers. If you select auto, it will power all the dampers open for 30 seconds and then power them all closed for 30 seconds. While it's doing this, it's looking for amp draw on the relays for each bank of dampers. Okay. If it sees amp draw on both the power open and the power closed signals, it will automatically detect your dampers. So it'll say damper 1, 2, and 3 in this case. It detected dampers on zones 1, 2, and 3. You can manually select this. However, this is a really good idiot test on your first setup through to make sure that everything got wired up right. Okay, you can do that. You can walk around, make sure all your dampers are opening when they're supposed to be opening and closing when they're supposed to close. Okay. After that, it asks you if you want to do your auto zone sizing. Strongly recommend this be done. Your auto zone sizing is going to use that static pressure sensor to determine how much each zone will handle. It does this through a process of running that blower motor up and looking at that static pressure sensor as it runs the dampers open and closed. So it does have a less aggressive, normal, and more aggressive setting. The less aggressive setting is going to optimize for a zone static of 0.45 in the duct maximum. A normal is going to set you for 0.6, and a more aggressive is going to be a 0.75 on those furnaces, 0.5, 0.7, and 0.9 respectively on air handlers. Okay. This generally, I just recommend guys use the normal setting unless they're trying to address a noise complaint. Sometimes you'll get whistling registers or something like that, where you need to bump that airflow down a little bit, or they're not getting quite enough capacity, so where you can bump that airflow up a little bit. So I'd probably start at normal anytime you do it and go from there. And what it's going to do is it will go out and run that blower at 100%. Now, on a 2-zone system, this takes about 20 minutes. Or excuse me, on a 4-zone system, this takes about 20 minutes. An 8-zone system is going to take about 45 minutes. Just kind of plan on that. But it runs each damper to 3 positions, 25%, 50%, 75%. And then it looks at the static pressure that's generated in the duct. So it does that for each zone. Then it starts combining zones and monitoring that. And it's just building that digital map for all the zones to see how much airflow they would tolerate. So this is just an example of some readings you might get on the same system versus if you're using the less aggressive, normal, or more aggressive set points. Okay, so normally it's going to size my zone 1 to 54% capacity, 48 and 42 for zone 2 and 3. You can see what it does for zones 1 for those same zones in the more aggressive setting. Okay, this is just kind of some rules of thumb, guys. If you don't have the static pressure sensor, or your ductwork won't accommodate the static pressure sensor, these are generic tables you can find out there. This kind of gives you a static pressure. This one's actually right out of the zoning manual, I should say. It gives you various CFMs for total system CFM, and it will tell you approximately what that 12-inch run is going to take, what that 6-inch run is going to take. And it gives you a percentage of that CFM. So you take 1200, multiply it by 11%, you're going to come out roughly 125 CFM for that 6-inch duct. So you can calculate this manually. It's not as precise. It doesn't accommodate your fittings. It's just educated guessing at that point. But if you didn't have room to put that static pressure sensor in, because I know they're out there, you can do it manually, and these charts are in the install manual. Okay. Once it's done doing your AutoZone airflow capacity, you'll see this screen down here at the bottom where it'll give you your zone sizes. So in this particular case, we've got a 43, a 40, and a 20% zone. It then gives you the option, if you accept those, then gives you the option to make those voting zones or non-voting zones. So any zone that's less than 20%, so this zone 1 cannot be selected as a voting zone. It requires each zone to be at least 25% in order to be a voting zone. Now, voting zone just means that it's able to independently turn the equipment on. Okay, if your zone is not voting, then it can't turn the equipment on. It will, however, still control the temperature in that zone anytime another zone is calling. It will add its load value to that zone. The equipment will ramp up to accommodate that zone and deliver the proper amount of capacity. But making sure that you minimize those non-voting zones is going to be critical to your success in making that zoning installation work the way the homeowner expects it to. So, but there are some good applications for non-voting zones. Okay, so once we get past zone size, voting zones, it's going to get you into the heating airflow offset. So this is really important if you run into a situation where your airflow for your heat and your airflow for your cooling are dramatically different. Okay. So if we have a 3-ton AC on a 60,000 BTU furnace, that 60,000 BTU furnace only wants to run 960 CFM maximum, but our AC is going to want to run 1200 CFM. It calculates our zone sizes based on our outdoor unit airflow. So in this case, we've got a negative airflow offset of 20% because my furnace is roughly moving 20% less air than the air conditioner. So we would set our airflow offset to negative 20% in this case. Now, if you've got the general rules of thumb, if you have a 2-ton AC and a 60,000 BTU furnace, those line up almost perfectly, no airflow offset. 3-ton AC, 80,000 BTU furnace, same thing. 4-ton AC, 100,000 BTU furnace, you guys get the picture. Okay, but be aware of this. We run into this quite a bit. And across our footprint, we have dramatically different loads. The guys up in Breckenridge, Colorado, are putting in 120,000 BTU furnaces with 2-ton ACs. Okay, we've got big airflow offsets there. Okay, so something to be aware of. The guys down in New Mexico, they don't know what a gas furnace is in some places. Okay, and so they may have huge AC, tiny furnace. It happens. So make sure that you're setting your airflow offsets accordingly. Okay, discharge air temperature limits are just that. Here in Utah, where I live, we always use the extended range because our air is a little thinner. We struggle with these discharge air limits. So we use that extended range just to eliminate nuisance trips. You can choose whatever you want. This is a table. So there's a little cheat sheet here. Depending on what type of equipment you have, these are the options it will give you. Okay. You can be aware that the minimum off time for a furnace is 3 minutes versus 5 minutes for a outdoor unit. Okay. But normal versus extended ranges. Like I said, I'm at altitude, so I always use the extended. If I'm at sea level, I'm probably going to use the normal. Okay. Just be aware of those options there that are there for you guys. This is just a little example of the zoning system that I've got set up in my training room. So we have our 1050 control here. This is the old 940 controller. This is what the rat looks like. And we have a wireless sensor down here. And I need a new picture because I've just added the color version of the 940, which is the 1040 to that one. So got some really nice zoning sensor options for you. This is a wireless temperature and humidity sensor. The thing to be aware of is once you've done all that in zoning, you've selected your voting zones, you've selected your limits, it's going to give you this screen that says you must assign the sensors. If you exit the installer setup screens without assigning sensors, it's going to disable your zoning. Okay, so you're going to go ahead and hit continue right here. It will take you to the service menu where you will now see an indoor sensor setup button. If you click on that, you'll have a list of zones. So this is zone 2, and you'll see we have an available 940 for this zone. So this 940 got addressed. We used to have to address those things to zone 2. So we can click on that zone sensor and hit assign, and it will assign that zone sensor, that 940, to zone 2. Okay. Same thing if we've got a wired zone sensor, even though it's wired into zone 4, we have to assign it as the active sensor. So we'll click on the available sensor right here. We'll hit assign, and then we've got that assigned. Zone 1 is always going to default to the 1050 or the 950. Okay. Now, if I wanted to add a wireless sensor to this instead of using the 1050, or I wanted to average, I would simply select wireless sensor down here. and it acts just like any Z-Wave device. These wireless sensors operate on Z-Wave, gives you 120 seconds to go to your wireless sensor and push this little install button, okay? So you'll notice a couple things on the inside of this wireless sensor. It has a serial number right here, and it also has the serial number printed on the sub base right there. So this is so that you can identify your zones, your wireless sensors if you've got more than one wireless sensor. So what I usually do is I'll go to the zone sensor and I'll actually write in here in Sharpie, right up in this area where you're not going to hit anything, just write zone and a number so that you know which zone that's supposed to be assigned to. Take a picture with your phone, then go down and set up your zone sensor. Okay, so these are the zone sensor 930s. These are wireless. They come with a pair of alkaline batteries. I strongly recommend you guys put some lithiums in there. They last a heck of a lot longer. My zoning system in my training room, I get about a year out of the lithium sensors. That being said, they're right next to the 1050. They don't consume a whole lot of battery connecting. You do have to be a little judicious of where you apply these wireless zone sensors. If you've got a house with a lot of interference, a lot of concrete walls, brick walls, metal studs, things like that are going to interfere with the wireless signal. The more interference you have, the harder that zone sensor has to work, the shorter the battery life you're going to see. So we do have a house that there was so much interference on the zone sensors that a pair of alkaline batteries was lasting 2 weeks. So A, use the lithium batteries, and B, be judicious where you use these wireless sensors. Make sure you're not going to cause yourself more problems down the road. They definitely have their place though. So once you push those buttons, it will show up as a wireless sensor that's online. It will say not assigned. Okay. And it will show up in any zone as an option. So we want to use it for our zone 1. We're going to select that wireless sensor and hit assign. It will then say we've got our 1050 onboard sensor. Once we assign the 940, it will say the 1050 and the 930. And you'll notice that the weight is 50% on each of them. So it's going to average between these two sensors. Now, if I didn't want to sense temperature from the 1050, I just wanted to sense temperature from the 940, I could click on this 1050 sensor and it would give me the option to unassign that 1050 sensor from zone 1. Okay. So once your zone sensors are assigned, you can then exit the installer setup. You go back there, you notice we've got zone 1, and that wireless sensor shows up with a wireless signal and a battery life indicator on the 1050. Okay, so it's going to be pretty important that you do that before you exit the installer setup. Otherwise, you get to go back through the zoning system setup. The nice thing about the zoning setup is once you've gone through it once, it retains all of your settings, so you can use those manual selections just to make it go faster. Okay. So that being said, any setup questions, guys? Okay, I'm going to show you guys my number one problem with zone sensors is that right there. What's wrong? So we're looking at the sub base of this zone sensor. Why on earth would this zone sensor give me inaccurate temperature readings?
Because you're using the furnace transformer wire.
Nope, this is a communicating zone sensor. It can pull power from the zone panel.
Open area behind the wall?
You have an open air passage through the thermostat. So it's going to pull, if your room gets pressurized a little bit, either positively or negatively, it's going to either pull air out of the wall or push air through the stat into the wall, most likely out of the wall. We generally have negative pressure zones rather than positive pressure zones. And so we are going to bias the sensor as that air flows through that sub base through the thermostat. And it's going to cause that sensor to read improperly. Okay, so always, 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 guys, make sure you are sealing up the holes in your walls, whether it's a zone sensor or a thermostat. Always seal up your holes. Did I mention you should seal up your holes? Okay, make sure the holes are getting sealed up. Tape is not generally a good seal unless it's backed up with some kind of putty or silicone.
Is putty better to use?
What's that?
Is putty better to use?
I've used the butyl putty before. It's pretty good. It stays put generally unless your hole's really big. In which case, sometimes you gotta do a little bit of drywall repair if your hole's really big. This hole you see here is about the limit for putty.
Firecock.
Yeah, Firecock works really good. I've actually taken aluminum tape, pushed the thermostat wire through the aluminum tape, and then Firecocked around it, and then put that onto the wall. The aluminum tape will help hold the Firecock in until it dries up. Okay. But we want some kind of barrier in there to keep air from migrating out of the wall through the sensor. Okay. So that's my number one trouble with sensors. Let's show you another little tool that's out there for you guys. So this is Nexia Diagnostics that I'm going to pull up here. You can access this through Comfort Site or AS DealerNet. I have a demo version of this that I'm going to show you. So this is just a nice little tool that's out there to help you guys when you're having those troubled systems, not just zoning, but anything else. And so this is what it will look like for you guys in your interface. You'll have all your customers listed here. So here we have, this is my dashboard. So this shows that currently on the demo systems, we actually have one guy that's got some critical faults. This one is actually zoned. So let's see what his problem is. He's offline. That's the critical fault there. He's offline. But you can come in here and you can see that you get status on all of your zones. Tells you how big your zones are. That's an awfully big zone. He's got all kinds of problems. Okay, it'll tell you load value of your zones, damper position. This one's been offline for a while. So let's go see if we can grab a different one here. I'll go to my customer list. And let's see if we can find somebody besides Skipper that's zoned. Here we go. Carl King is zoned. He's one of the factory guys that works down in Tyler. And you can see he's running a version of software that you guys don't have quite yet. He's one of our test sites. You can see everything about his system. So he's in automatic. Outdoor unit is in idle. He's in heating stage 2 on his indoor unit because it's freaking freezing in Texas right now. Fortunately, he has power. You can see his total system load value. So he's above 100 on his load value, so he is calling for stage 2. And you can see all of his damper positions. So right now, load value primarily is in the kid's bedroom. And that zone size is 40%. So he does have some excess air that he's got to deal with. So the strategy that they're using to deal with his excess air is to actually crack those dampers open 25% to that minimum position to bleed some of the excess air off that he's got in this zone. That damper looks like it's in motion right now. Okay, we can also come down here and we can see all of his zones. As we cursor across, you can see down in the bottom left-hand corner of my screen that you've got all the current status of the zone. So let's zoom in here a little bit. So down here on the bottom, you can see where the furnace is in first stage versus modulating stages. I think he's got a modulating furnace. Let's check. Yeah, he's got a modulating furnace. So modulating range is anywhere inside stage 2. So you'll notice we have several different levels of the dark red. And you can kind of see in here these little bulged out spots. And if you notice, if I'm on one of those, it's calling for that kid's bedroom, which is kind of small. that zone size was only what, 35% or 40%. So it's a little small for the lowest stage furnace. Doesn't tell me what size of furnace he has. Might give me his outdoor unit though. Nope. Doesn't give me his model number. Okay. But we can see that anytime that the kid's bedroom is the only zone calling, he has a little bit of an excess air problem, because you can come down here in the bottom left and you see that damper position's at 25%. And you see that the lines are all a little swollen right up here. That means that we're getting some relief in those situations. However, if we come over here, like right here, we're seeing that the living room zone is calling. So it's opened up that damper to 54%, which is minimum, matching my airflow for that zone. There it is, it'll open a little more. Okay, and as we cycle in and out of these other zones calling, you'll notice that all those other zones, which were sized a little bigger, so the living room and the master are sized a little bigger, we don't have any air relief problems in those, because it's able to run that airflow on that furnace down enough that it doesn't have an excess air problem. So now the diagram can be a little muddy, so you can come in here and turn off any set of data points. So if I didn't care about any of the cooling data points, I could click these check marks for the cooling, and it will make my cooling set points go away. And I'm hosting a Zoom session, so this is going to take its dear sweet time, but we can see those cooling set points going away here. If I only want to look at one zone, I can click off all my zones except, say, the living room, and it'll make all my data theoretically go away except for the living room. Taking its dear sweet time. There we go. So there I have just my living room. It'll clean that graph up as much as you want. You can zoom in as far as you like. But we get all of our operational data. And so I use this tool quite extensively to help guys with their zoning systems and with their regular systems even. This operational data, guys, will go back. This guy's in Tyler, Texas. It's freaking freezing in Tyler, Texas. He's at 24-degree outdoor air temperature. He's hating it. Fortunately, he's still got power though. So this data will go back 60 days. So we can go all the way back to when it was a little warmer back in Texas. There we go. So this is the weather that they're used to. Aaron, if you still can't hear me, you might try the call-in number that's in your meeting invite. But you know, we can get whatever data we want out of this thing we want, guys. You can go to anywhere you want, and it will help you with your diagnoses to have that background context. Because invariably, when we get complaints about zoning, it always goes with this big set of caveats or set of circumstances that we're hardly ever able to replicate in the field. You know, they'll say when the master bedroom and the living room are calling at the same time, it has a problem. Well, this allows me to select that master bedroom and that living room and see what they're talking about. Okay. In this case, it's most likely we're going to get that call that the kid's bedroom, anytime the kid's bedroom's running, we get air out of all the other vents. Well, yeah, it's because the kid's bedroom's a little small, and so it relieves into all the other zones. We can see that fatter line right there where we're getting relief air into my living room zone from the kid's bedroom. Okay. But this is a really cool tool, guys. that's available to you. I highly encourage you to use it. You can access it off of your comfort site. And that's just under the Nexia tab. And then you guys will select Nexia Diagnostics and get something that looks like what I just showed you. My Nexia Diagnostics is a little different because I have the super special access level. But yours will look like the one I just showed you. Any questions, guys? Any questions about anything we covered this evening?
Yeah, a real quick question for you. I've been using the Nexias on the single stage, no zone systems. And I, had to recalibrate everything else. But can I go to that website to go back to set everything up to factory settings?
You can actually. There's a little bit of caveat there. Let me pull that back up. So there is a remote configuration option.
Okay.
So if we get into my Nexia Diagnostics demo, we'll see if it'll do it for me.
Yeah, I've just been having problems at the location. They're running their security systems off of that, blah,
Yeah.
blah, blah. The recalibration part, I get it, but the Nexia is a new product that I've personally been using, and the zone systems are pretty cool. But I'm really glad that you brought up the Nexia. I'm just trying to figure out.
Yeah, let me grab a customer that's
just a simple
not
application.
having troubles.
Just a simple application to get it back to factory settings, because these guys are doing it for security, all kinds of craziness, and I just ended up replacing just the whole new thermostat for this one gentleman because he's an older gentleman, and long story short, it was just super goofy.
Yeah, so if you're on site, you can do it through the installer menu.
Okay.
There's a reset defaults. You
Okay.
can actually get in, and there's this option to request remote access here.
Okay.
If you're off site, you get the homeowner on the phone because they're going to have to grant it to you on their thermostat.
Right.
But it'll pop one of these messages up on their screen.
Okay.
And they can hit accept. Once they hit accept, you'll have the option to go in and enter into that thermostat, and you can reconfigure it remotely, just as if you were standing in front of it. It'll pop up on your screen just like a normal thermostat interface.
Okay, cool.
So unfortunately, I don't have one that I can dial into right now.
No, that's fine. I just this is a new product on all of our multi-families, and I just trying to, I've been on tech support, and I've kind of read some things on it in the manual, but it's pretty vague. And the only thing I've only realized to do is just recalibrate it, but I want to just try to go back into factory settings.
Yeah, so any of the 1050, the 850, the 824s will do that.
Right. And we're using the 824s right now.
Okay. Yeah. If you go to the 724s, they're not quite the same thing. You don't have that remote access option, but there is still a factory reset in the installer menus.
Okay, awesome. Thank you.
Yeah. What other questions do we have, guys?
Ethan,
Yes, sir.
can you use a wireless sensor on a 950 thermostat with zoning? I had a feeling you're going to say that.
No, you can't. You do need to upgrade to the 1050 in that case because the 950 does not have a Z-Wave radio to talk to that 930 wireless sensor.
But my 950 has been super accurate and running great for 10 years.
Good on you, man.
Yeah, but we're changing the house over to zoning.
Okay. I would strongly recommend changing over to a 1050 if you're going to use it, and you get all the software updates.
With plaster
my
walls.
parents' 950 is still running as well. They're pushing 10 years now. So.
All right, thanks.
What other questions, guys? All right, guys. Well, if there's no other questions, that's the class. Thank you for coming. The recording will be available on the website here shortly. As soon as we get it downloaded from Zoom. which will be an interesting feat on a 3-hour class. But I appreciate you guys coming and participating. And if you want a copy of that manual, make sure you send me an email. My email address is at the top of the chat right now. And if you have any other questions that come up, please feel free to reach out. We're here to help you guys. So thanks for coming. Have a great evening. If you have more questions, you want to stick around afterwards, more than happy to answer them.
Thanks.